Welcome to Study Loop.
This is chapter 21, problem number 80. Efficiency of a transformer is given to us as 88%, which means the secondary power generated by it is 88% of the total power. So we can write it as 0.88 times the primary power, right? So the secondary power is given to us as 75 watts. And the primary voltage is 110 volts. We are asked to calculate the primary current in part A. In order to address this, we need to remember the primary voltage times the primary current equals to the primary power. So then let's use this first equation and let's plug it in for the primary power. So when we do that, the secondary power equals to 0.88 times the primary power, which is primary potential times the primary current, equals to 75 watts. Then if we divide both sides, well, let's just work with the symbols for now. So if we divide both sides by 0.88 times Vp, 0.88 times Vp, then for the primary current we have the secondary power divided by 0.88 times the primary voltage. Now we can plug in the values. 75 watts divided by 0.88 times 110 volts. Then the primary current is going to turn out to be 0.77 amps. Now in part B, we are asked to find the ratio of the number of turns in the primary portion to ratio of the number of turns in the secondary. So, well, as we know, this is proportional to the primary voltage divided by secondary voltage. And, well, we know what the primary voltage is, 110 volts, but we haven't calculated what the secondary voltage is right now. In order to answer this question, we need to do that, right? So the secondary power equals to the secondary potential divided by the resistance, right? Then from here, let's try and isolate the secondary potential here. So secondary potential squared is going to be equal to secondary power times R. If we take the square root of both sides, the secondary potential is going to be equal to square root of p sub s times R. We can plug this in the previous equation. Then the primary voltage divided by square root of secondary power times the resistance, right? So this is 110 volts divided by 75 watts times, well, the resistance is given to us as 2.4 ohms. Then this ratio, we're going to find out that it is 8.2.